G'day and welcome to the third video on the normal distribution. This video will look at how to standardise a score, how to compare two different normal distribution scores, or distributions actually, together. So the normal distribution is a valuable measure of continuous probability distributions. However, by themselves they can be a little bit limited. Imagine the following distributions are of a recent SAC task and a SAC test. So we assessed both a task and a test, and we wanted to, rank you guys from best to worst based on the scores. And the task and the test had slightly different means and standard deviations. So if you have a look here, the SAC task has a mean of 80 and a standard deviation of 8. It's a variance of 64, but standard deviation of 8. And the SAC test had a mean of 55, a much lower mean, but a much higher standard deviation of 15. So the data is more spread out in this one. So most people end up getting around 80% for this one, but like here, some people, 55% was the mean, but there was a massive standard deviation there. So it's pretty easy to see that the assessment pieces gave very different indicators of ability and difficulty. Clearly the mean and standard deviations are different on each task. How can we compare scores of the task with the scores of the test? So for example, if you take the score of 85 in the task and 60 in the test, which one was a better mark? Or maybe what I really want to ask is, which one beat more people? Did 85 out of 100 in the task beat more people, or did 60 out of 100 in the test beat more people? That's essentially what we're sort of asking. It's very difficult to compare because they're different standard deviations, different means. Both of them are only 5 marks more than the mean, but the standard deviation makes a difference, and that's what we want to compare today. So if you want to compare values in two different normal distributions, we can reduce them down to the values of the same standard, and that standard we're going to call the standard normal distribution. This distribution has a mean of 0 and a standard deviation of 1, and it's represented by the letter Z. Okay, so I'll show you exactly what I mean by that in a second, but if this is the normal distribution, that's the function notation for a normal distribution. This is the function notation of a standard normal. So it's Z rather than X, and but it follows the normal distribution with 0 as a mean and variance of 1, and also standard deviation of 1 as well. Okay, and if we want to compare a Z score with an X score, or an X score with a Z score, we can actually use this formula here to convert our observed value, our X value, into a Z score. I'll show you what I mean in the next little section. So we can use this process to determine what percentile each score, 65 and 60, is in, 85 and 60, and therefore which one is the higher task. So imagine if you've got this particular situation here. This is the SAC task with a mean of 80 and a standard deviation of 8. But what I'm actually saying is that I'm going to compare it to the Z score, which has a mean of 0, and so these correspond to each other. So mean of 0, 1 standard deviation is 88, or 1, 2 standard deviations is 96, or 2, and then 1 standard deviation on the other side is -1, or 72, and -2 and 64. What I really want to know is, I want to know where is 85. Okay, that's what essentially I'm after. 85 is about here. So what I can do is I can find out the area of 85, but I can also find out what Z value it is. And the Z value will tell me how many standard deviations away from the mean it is. And that will tell me, if I find out for both of them, that will tell me which one's the better score. So most of the time we've been dealing with 1 or 2 standard deviations away from the mean. Sometimes it might actually be, half a standard deviation from the mean, or 0.7 standard deviations away from the mean. And that's what I'm going to work out right now. So if I want to convert this observed X value, this 85, into a Z value, because I can compare this Z value with the test Z value, I get this formula here. Z equals X minus the mean over the standard deviation. And the Z value is just simply how many standard deviations away from the mean it is. Is it 1 standard deviation? Is it 2? Is it 0.5? Is it 0.6? And that sort of helps us a little bit. So 85, which is the mark that I got, minus 80 divided by 8, because mean is 80 and standard deviation is 8, and I end up getting 5 out of 8. So I know that 85 is 5/8 away from the mean, and 5/8 of a standard deviation away from the mean. Okay, which is quite helpful. Now I'm going to do the same thing for the test, and here I need to know what I think it's what 60 is. So 60 is somewhere in the middle between 55 and 70. So let's just say it's about there. What Z value will that give me? Because once I know the Z value, I can compare the two different Z scores, and therefore I can know which one is actually ultimately a better score. So the Z value is really helpful for this because we can compare two different scores. So X minus the mean over the standard deviation, I end up getting 60 minus 55 over 15. I end up getting 5 out of 15, which ends up being 1/3. So as you can see, the SAC test, I got a third of the way, a third of a standard deviation away from the mean, but the SAC task, I got 5/8 of a standard deviation away from the mean. So this one, I actually beat more people than I did for this one. And I could find out how many people I beat, I guess, if I actually calculated this on my calculator, and I probably will do that actually. If I go to my calculator and I say, how many people did I beat for both? I'm going to find out by doing normal CDF, and I'm going to make it from negative infinity up to 5/8, and I'm going to make the mean of 0 and the standard deviation of 1. Okay, and I end up, that means that I beat 73% of people. If I do the same thing again, but instead of having 5/8, I have a third, I end up getting, I only beat 63% of people. So the SAC task is actually a better score, and that's what I can write down here. So the SAC task ended up being a better score because I beat more people, and that's the name of the game, to beat as many people as you can. So in the next video, I'll explore a couple of other examples about the normal distribution, but that's essentially, so the standard normal distribution, that's essentially how it works, how we compare an X value to a Z value. So thanks for watching, and make sure you watch the next one.